second program which we will be studying today. So, as the question says, of the second program, create and rotate a triangle about the origin and a fixed point. So, this is the question part of your program laboratory, that is second program. Um, uh, Before moving on to the other slides, before moving on to the program, I would just remind you people, once I finish up this laboratory part, that is the class explanation of the second program, as I give you some time, right? So at that time you need to execute the program and then upload the snapshots of the output in the Google Classroom, where I have posted the class work, that is the second program there. You need to upload your snapshots of the output there. Then, so let's see how to rotate a particular triangle about a origin and a fixed point. As we studied in the theory classes, there is something called 2D pivot point rotation we studied, right? What happened in 2D pivot point rotation? What is this 2D pivot point rotation? Two-dimensional rotation about any other pivot point. Suppose there we have two coordinates, x coordinate as well as y coordinate, by performing the following sequence of translate, rotate, translate operations. As I have explained you how 2D pivot point rotation works, I can call 2D pivot point rotation as translate, rotate, translate operation as well. As I told, there are three steps involved in 2D pivot point rotation. One is translate the original object, then rotate the object, then again translate the rotated object. So what happens in the translation of the original object? You should translate the object so that the pivot point position is moved to the coordinate origin. That is nothing but, if you have x and y axis, we'll see in the next slide how this performance is done. That is, this is actually a repetition to you how the theory part works. In translation, that is the first step, the pivot point position is rotated, or not rotated, it is translated to the coordinate origin, that is the original origin of your particular object, that is nothing but triangle in the program. Then I will rotate the object about the coordinate origin, then I will translate this particular rotated object. So let's see how diagrammatically I can represent that. As I told, what is the first step? The first step is translation of object, then rotation, and finally there is translation of object so that the pivot point is returned to its original position. There, in the first part, yeah, in the first part, in the figure A, what does this represent? It basically represents the original position of an object and a pivot point. I can call this as a pivot point. This is the original object with respect to that pivot point. I can represent it as xr comma yr. So this is the original position of an object I have represented in the first diagram. In the second diagram, I'll be translating this original object to a pivot point at its origin. With the help of this pivot point, I will translate this whole object to its origin. I can call this as an origin with respect to x as well as y coordinates. I am just translating this to this form, that is, I am moving this object towards the origin, that is translation of object. Then I should rotate this object. This, as I told, this is the basic procedure of pivot point rotation. Once translation is done, this translated object is being rotated about the origin with respect to x as well as y axis. Once the rotation about the origin is done, I should move this particular rotated object with respect to its origin to the original position. That is nothing but I should move this whole object toward the pivot point. That is nothing but translation of object so that the pivot point is returned to the position. Now the pivot point is here, right? Because I have rotated this translated object, the pivot point is at its origin. I will need to move this pivot point to its original position. So I'll perform again translation so that this object is been translated to the original original pivot point position there. So finally, I will get this as a translated object as the resultant of an pivot point rotation. Is the theory part clear to all about pivot point rotation, 2D pivot point rotation? Any doubts you have here? Yes, no. You people have any
No,
doubts?
sir.
Yeah, you need to just remember translation, rotation, as well as translation. Translate, rotate, and translate. This is the basic procedure of pivot point rotation. So let's see how to code it, how the program works. Um, as your OpenGL program consists of libraries, you need to define a preprocessor directive. Some of the preprocessor directive which consist of libraries, I'll be defining studio.h as it is a C program, and then I'll include the library called glut.h, which is the main library for throughout your all the programs. I'll define two variables that are x and y, which are of type integer. I will define one variable called as where to rotate, which is of an integer, and I will initialize it with a value called 0 there. Then I will define three different variables called translate x, translate y, as well as rotate angle with respect to that particular object of type float, which has the values 0, 0.0, as it is a floating point values. As it consists of floating point values, I will assign 0 to each and every variable here. So what does this basically tells? Current translation parameter value and rotational angles of the shape. That is nothing but how which value to be translate. As I told, the pivot point rotation is of three steps: translate, rotate, as well as translate. I will define those variables here of type float here. So as everyone know, each and every C program C program's execution starts with the main function. So this is the main function I have defined here, int main, which consists of parameters called argument count as well as argument vector of type integer as well as character. Then the command, once the control comes to this statement, it asks the user to enter the fixed point so that you can perform rotation with respect to x as well as y axis. Then it takes the input from the user, that is x and y value is been taken from the user. Then I will initialize the glut library with the parameters called argument count as well as argument vector. Then I will tell what kind of display mode is being defined with respect to the output screen. That is nothing but it consists of double buffer, which consists of the RGB colors with respect to glut library. Then I will set the window size as well as window position. I will give the window size, that is nothing but width as well as height as 800, 800, and then I will give the window position, that is nothing but top and left corner of the window is being displayed with respect to this command. Then I will create a window with respect to this name, that is nothing but with the help of this command glut create window, which consists of the name rotate created triangle. Now I'll call a function here which is nothing but init function, which basically tells OpenGL initialization. Once the control comes to this function, that is init function, it will directly jump to that function. So let's move on to init function. See here, once the main function is been executed, the command, the control executes still here. Once you will get an a window of this particular title. After that, initialization is done. OpenGL initialization is done. Once the init function, once the control comes to the init function, it will directly jump to this init function. So let's see what initialization is done with respect to OpenGL here. Basically, with the help of GL clear color, the background color is set to white as well as opaque. What is the values? RGB. All the values is given one. So the background color will be white, and then I will give the alpha value as 1. And I have defined some commands here to carry out the transformation with respect to matrix mode to different matrix mode. What does this matrix mode tells? What this load identity tells? So let's see that. This slide is basically about these four commands. What are these commands representing? To set the clipping area, we need to issue some series of commands, right? So that the clipping area, the wanted part of that particular screen, if you want the wanted part by eliminating the unwanted part as the clipping defines, so what is the procedure? You need to select some projection matrix for the operation, and then you should reset the projection matrix to the identity matrix, then choose the orthographic view with the desired clipping area. So that is basically the command specifying there. Check out here, what does GL matrix mode tells? It basically selects the projection matrix for the operation. Projection matrix is being set as well as taken from this command here. Then I will give GL load identity, with the help of which projection matrix is set to identity matrix there. Then I will define GLU ortho 2D, which consists of some parameters which basically tells the clipping area left, right, bottom as well as top. These are the parameters given to orthographic view of the desired clipping area. So look out here. What is this here? Yeah, as I can tell, this is the clipping area as well as the viewport area. What is the clipping area? What does it define? What is the definition of clipping area? I can tell that it is just the wanted part of an original picture. To define it simpler, I can tell clipping area as the clipped part of an original object. What is the viewport? Viewport is nothing but a section which displays the clipping part of the original object. So with respect to some x and y axis, I need some clipping part. I want to clip this object, this as well as this object. If this is the clip part of your original object, with the help of viewport, I'll be displaying this clipped area onto the viewport screen. So that this is what this GLU ortho 2D, this is the orthographic view of that particular object. If this is the original object, the orthographic view of this object is this way, which you can represent with the help of viewport, which will be in the form of pixels there. So this is what the previous function defines. First, it will basically create the background color as white, and then it will check the projection matrix here, and then it will replace the projection matrix into identity matrix. Then it will set the orthographic view for the original object, and it will basically defines matrix mode. As I have defined the matrix mode here, this matrix mode is being defined with respect to model view. What does this model view does? It will carry out model transformation where the matrix mode is set to GL model view. So this is what the init function does. Once, as I told, once the control comes here, it will move on to init and perform initialization of OpenGL. Then there is something called as GLUT display function of display. What is this? This is basically a callback function, I can tell, where you are calling that function in the main function before defining it, right? So GLUT display function, it is used to handle a window for repaint event. So let's see what is this GLUT display function does. So if I go to the GLUT display function, as as in the main function, once the init function is called, it will directly jump to the init function and then perform initialization of OpenGL. Then once the control sees the GLUT display function of display, which consists of the parameter display, it will just move on to this function that is nothing but display function, and it perform the operation. So let's see what happens in display function. First, the buffer bit is being set here, where it will basically clears the color buffer, that is nothing but clears the background, and then it will load the identity matrix to this particular buffer. Then it will give the color to the point with respect to which you want to rotate the object. So here there is point, the first point is displayed there, which is of type red here. Look onto this screen. This is the window screen you get, where you get a point here which is of color red. Then I have called a function called draw pixel, where the pixel where the drawing of an object starts here, the draw pixel function. So let's see what is this draw pixel function. Once the control comes to this draw pixel function, it will directly jump to that draw pixel function. In draw pixel function, as I have two parameters, that is 0 comma 0 defined before in the function, in void draw pixel I have defined two variables x1 as well as y1, which are of type floating point value. In draw pixel function, I will first define the point size. I will define the point size as 5.0. I will give the primitive as explained in the theory classes. GL begin. This basically tells you beginning of the function as well as ending of the function, where you need to define the vertex of that particular point, which is of type floating point, which has two parameters x1 comma y1. So I once this a function is being executed, a point is being displayed there. A pixel, that is, I can define a point as a pixel where the x as well as y coordinate is of 0 comma 0. Then it will end that particular pixel function, and then it will move on to the another commands. Now, draw pixel function is done. After draw pixel function is done, it will check a condition as where to rotate. It is being defined as 0 in the initial step. It will check if this command where to rotate, if this variable is equal to 1. If this is equal to 1, these two translate x as well as translate y will be equated to 0, and it will rotate that particular object. That is nothing but the formula for rotating is rotate angle is equals to rotate angle plus 0.9. That is nothing but the default value of that. Where to rotate? If that case, if it is 1, this whole commands will be executed. Or if it is false, it will check for the another condition. If where to rotate is equal to 0, it will translate this particular x, it will assign, translate x to x and then translate y to y. That is nothing but translation of this particular object with respect to x-axis will be assigned to x, and with respect to y, it will assign to y. Then it will change the rotation angle about each display. That is nothing but rotation angle will be equated to rotation angle plus 0.9. That is nothing but the default size, default value of the rotating angle. Then it will set the color of that particular pixel of the second point where you have to rotate. That is nothing but where to rotate that point, right? First, the object will be here. Once this where to rotate function is being executed, once this condition is satisfied, it will just rotate the object to that particular point. That is nothing but I have defined the point color as what? Blue, right? RGB. This is defined as blue. The point is displayed as blue. Then again, draw pixel x comma y function is been called here. So let's see how this rotate f as well as translate f works there. As once the draw pixel function is called, it will, after checking of the conditions, if it is equated to 1, equated to 2, equated to 2, all the parameters are being executed, then the control comes out of these loops, and then it will execute GL translate f. What does GL translate f? It does, it basically translates with respect to x as well as y axis, where the value of that point will be 0.0. So let's check out here what is, as I have defined GL translate f as well as translate f as well as rotate f here. So what does that function does? Void translate is done by a GL translate function, that is translation function is done there. As the pivot point rotation, what is the procedure there? First translation is done, then rotation is done, then again translate is done. So first GL translate function, it basically gives some vector to the function. Void GL translate f with respect to x, y as well as z, which are of type floating point values. These are some of the translational vectors which is being defined in the function. Then how rotation is done? Rotation is done with respect to GL rotate f, which consists of one angle. As we know, rotation is done with respect to some angle. You need to define an angle, and then you have three parameters x, y, and z, which are of type floating point values, where angle specifies the rotation in degree. This angle should be in degree. X, y, z's are nothing but the axis of rotation. We have something called as glut post redisplay. Once this control checks out this particular command, it basically calls a window request so that it will return to display function. Once this is called, it will again go to the display function and then execute with respect to these points there. So this is how GL translate as well as GL rotate function works with respect to different parameters there. Then you can see here as the 2D pivot point rotation happens with respect to three functions. One is translate, rotate, as well as translate. This keeps on rotating there. Then I want to display a triangle. What is the question says? As I told, what does the question says? The question says create and rotate a triangle, right, about the origin and a fixed point. So now let's see how to define a triangle with respect to those points. I have called a callback function here, which is of type triangle, which consists of two variables, that is translate x as well as translate y. So once the control comes to this triangle function, it directly jumps to the triangle function. So what happens here is, so let's see, I have defined void triangle, which has consist of two parameters, int x comma int y. It will, in this function, first it will set the interior color of the triangle, that is nothing but with the help of GL color 3F 0 1.0 comma 0 RGB. This basically specifies the triangle inner color of the triangle should be green. As we know, this is a kind of polygon. I will start defining the primitive as a polygon, and then I will start defining the points of that particular polygon. The first vertex of that particular polygon is x comma y, that is nothing but the origin. The origin is set to x comma y, that is 0 0. It is defined here. Then I will add that particular x. The initial value of x comma y will be 0. This will be added to 400 plus 400. This might be any value which you define which you define in the previous point section there. Here 400 comma 400, then vertex 2f x plus 300 comma y plus 0. So if you specify this whole vertices function here, the triangle will be displayed onto the screen there. As till now, what happens is, this is the output screen you get. Once you enter the fixed points for the rotation as 100 comma 100, the control keeps on waiting to this triangle function to be executed there. Once this triangle function ends, that is nothing but GL end as well as GL flush is done, the whole program is being set to a buffer where it keeps on looping itself there. Once the void, what was it? Once the triangle function is done, we'll move on to the next function, which is nothing but glut post redisplay. Once this glut post redisplay, what does this does is, glut post redisplay, it basically marks the current window as a, as I told, it will again go to the display function repeatedly. Then it will swap the buffer so that the window is been two times buffered with respect to the particular object which needs to be done. So this is what about the void display function which is being defined here. This whole display function, as we studied in the main function, the display function, what does it does that? So this is what the display function does with respect to your program. Then once the display function is done, it will move on to the next function, which is nothing but create menu there. What create menu does, once you have the rotated object onto the screen, you need to display some menu there. Menu, yeah, you need to display a menu onto the output screen. Once you find this particular function, it will directly go to the rotate menu function where it should have some options. So this is the rotate menu there. In the first option, if the option is equals to 1, if you press the option 1, it should rotate around the origin, that is it should rotate with respect to this origin. If you press the option 2, it should give it should rotate that particular object around the fixed point with respect to some point. If you press the third option, it should stop rotation there and then start displaying. So once you get the rotated object onto the screen, if you right click onto the screen, you will get this particular menu there. Once you get this menu, if you click rotate around origin, the object should rotate around the origin. If you click the second option, rotate around fixed point, it should be rotate. It should rotate with respect to a fixed point. If you give stop rotation, the rotation should stop there. So this is about rotate menu option there. Then once rotate menu option is called, you'll create a menu there where with respect to that menu, you should have three options there. The first option should specify the menu entry as rotate around origin. The second should give rotate around fixed points. The third should give stop rotation there. Then you something called as you have attached menu where it consists of, this is one of the cursor parameter which you are passing to glut attach menu there. Oh, once you right click with the help of your cursor, these options to be displayed there. Then with respect to this cursor options, we have one function in the program, that is, yeah, with respect to this function, once, as I told, once you click the right, once you give the right click here, you should get this particular options where to rotate. Once you give this particular function here, where to rotate function comes to this particular condition and checks. Once that function is done, if you give where to rotate the option as 2, it will again come and check this particular function. That is nothing but this, if this condition is met, the whole function is being executed there. Then in the main function, we are checking out the main function, right? Once the entry of that particular options is done, the whole program is put into glut main loop, which basically it keeps on happening there, event processing there. The events keeps on repeating. It's kept into a loop where till you get the output, this whole function is being, the whole main program keeps on executing in a loop function there. So let's check out the output, how it displays the output. So I have put the snapshot of the output here. First, check out here. Once I give 100, 100, the first fixed points of the rotation. As I told, do remember the compiling command and then execution of the output command is this. I'll give the points as 100, 100. You will get an triangle with respect to 1 point. Then once you get the triangle here, you should give right click to that particular output screen. Once you give right click here, you will get a what? You will get a menu here. Once the menu is being displayed to you, if you click these three options, any of the options, it should perform those operations with respect to whatever you have defined in the menu. So do remember, once you get this output screen, don't stop here itself. Give a right click. Once you give the right click, you will get this particular menu. Once the menu is displayed, you can click onto any of these three options. Once you click if rotate around origin, this object will be rotated on some particular origin, or else if you give the second option, the second option is performed, or if you give stop rotation, the rotation is stopped with respect to that particular origin itself. Is this clear to all? The output screen, and if you have any doubts in the program, you people can ask me now. Any doubts? Am I audible to all? Students, are you there?
Yes, sir.
Yeah, you people have any doubts in the output or in the program?
No, sir.
No. Oh, do remember this. You people will forget. Once you get this rotate, created triangle screen and the rotated object here, you need to press right. You need to right click onto the screen. Once you right click onto the screen, you'll get another window which consists of this menu With this menu consists of three options, which we studied in the create menu function, which consists of rotate around origin, rotate around fixed point, as well as stop rotation. After you get this menu, you can click any of the one option here with respect to which the operation performs.